recording this? I am now. So, isometric sketches exercise 1, number 1. I drew the block and now I'm going to cut out the top portion of this block. So it should be slightly more than halfway. Something like that. Now, obviously, if you can see what the final part should look like in the isometric, then you don't have to go and do this whole cutaway method. This is just for people who are battling to see what it should look like. Okay, so there I removed that little step. Now, if we view the right-hand side, we can see there's a 3 wide, 2 high block cut out here as well. But now the question is, how deep is this cutout? So to get that information, I have to go to the other views. So if I go to my main view, if this cutout is over here, it can stop against this vertical line over here. I can also use the top view to see how deep this cutout goes to the back. If it was stopping anywhere other than that line, I would have another edge or line visible in my main view. So this block is cut out all the way to the end over here. So the question now was, does the first edition and second edition have the same exercises in the drawings? Yes, they do have the same exercises. Okay, so next we're going from this line's middle, somewhere there, going down 2 blocks, to the side 3 blocks. Now I'm just going to erase all the stuff that I don't need anymore. Okay, so let us reflect and see if it makes sense. So this flat plane of mine, if I view it here from the right hand side, then that whole flat plane just becomes a straight line. If I can show it to you, like there's a cell phone and the top is a reasonably flat plane. Now, if you view a flat plane directly from the side, this top surface now from a flat plane simply becomes a straight line. So that's why this flat plane of ours, if we view it here from the bottom right hand side, it is simply represented by that line in the right hand view over there. So if I tilt the flat line and view it straight from the side, then the surface just becomes a straight line. Can somebody else hear my audio? Oh, okay, I'm glad that you can hear the audio. So maybe it is just then with a few students. Maybe check your sound settings, and someone says you can maybe try refreshing your page. Thanks. It cracks up. Oh, it caught my joke from yesterday. Sorry, that was just a bad joke. Okay, so from the top, this rectangle will be represented by that rectangle over there. This next rectangle, that one there, from the top will be represented by that little rectangle over there. This big rectangle over there in my top view is then just that one there. I'm glad you came right. So it seems refreshing does work. Good. If we view it here from the front, the first thing we encounter is this L shape over there. So in my front view over here, we see the L shape. And then as we move further back from there, we get this rectangle over there, which is in my isometric view, it's that one over there. So now we can see that this isometric drawing of mine does actually correspond to that orthographic sketch in the question. So this is then the answer to this problem. I'll leave it on there like that for another minute for the students who want to copy it down to be able to do so. Okay, that's a good question. What speed should you do an isometric at in a test environment? So typically a semester test in MGC will be a 3-hour long session where probably a quarter of the time can be spent on the isometric drawing if you proportion the time and the marks linearly. So a quarter of 3 hours would then be 3/4 of an hour. So if you, for the first semester test, you can spend probably, if you do half an hour on the isometric, you'll be fine. What about center lines? So this drawing does not have any center lines because there aren't any arcs or radii in it. So this one looks just like that. Okay, the next one is exercise 1. Number 3. Good, isometric sketches, exercise 1, number 3. This time we have a main view, a right-hand view, and a top view again. Main view has a height of 1, 2, 3, 4, 5, 6 blocks, and a length of 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks. So it's about 1.5 times as long as what it is high. The right-hand view has the same height of 6 blocks and a width of 1, 2, 3, 4, 5 blocks. The next question was, should you use different colored lines? please don't. We just get pencils in kind of like a dark grayish black color. Don't use other color pencils, please. Okay, next one is this one. Let's see if we can quickly draw it. So we have a view on this side that's more or less 30 degrees. There I have my isometric box. Next thing we need to do is we need to try and figure out what this thing would look like. So if I view the main view, I can see that I have a line like that and a smaller one on the top right hand side. So lines represent edges, or a fancier term would be a change in plane. So there's something happening and there's something happening. In my top view, I have from this corner, which lines up over there, I have a line going 2 blocks in, and the same with this one, 2 blocks in. This corner, if we project it upwards, corresponds to that corner in my top view. So this corner in the main view is that corner in the top view. And it also goes in 2 blocks. So I'm going to now start by drawing these two, let's call it diagonal lines of the main view onto this isometric box of mine. The first one starts 2 blocks from the top left, and it ends just to the right of the middle. Something like that. The second one starts 2 blocks from the right, and it ends 2 blocks from the bottom. Then in my top view, I saw that this corner has a line going to the back. That would be that line over there. Line to the back. With a length of 2 blocks. So just something for interest, if that is 2 blocks and that is 2 blocks, then it means that this point must be directly above that point. Then I've got a straight line from that corner to that corner. Straight line from there to there. Good. Then I also saw that there's a straight line going back 2 blocks from this corner, so something like that. And now I'm kind of stuck with the information of the main view. I have to now use information from the other views. So from my right-hand view, I can see that there's a little 2x2 box that either is protruding out or is cut in. So that corner over there lines up with that corner caused by that line there, which means it can look something like that. So there's the 2x2 box that is cut away. So now I'm just going to erase the stuff that I don't want there anymore. Okay, good. Now we need to finish this drawing so that it makes sense. So I have somewhat a flat plane over here, but at the moment my flat plane isn't completely sketched because it's open on the one side. So if I view in my top, I've got this little rectangle over there that is 2 blocks deep from the top line to the bottom line. So 2 blocks deep. From the top line to the bottom line. And then we also have this plane over here, which is this one in my main view, which at the moment isn't completely drawn yet because it is still open at the bottom. So to close that off, I need to do that. And that is basically the isometric drawing in this question. Let's have a look. If we approach it from this bottom left-hand side, we have this shape over there, which then corresponds to this shape here in my main view. Over here we have the little triangle like that, which then corresponds to that triangle over there. If we move it a little bit further back, we have this shape over here, which goes from there to there, to there, to there, to there, which corresponds to this shape over here. And if you look very carefully, you'll see that there's a dashed line over there. Let me zoom in a little bit for you. So that dashed line represents somewhat the plane which is behind the part that I'm looking at, which is basically this flat plane that lies behind this edge over here. So the dashed line represents the hidden detail of this flat plane. Good. Oh snap, I shouldn't have clicked there. There we go. Okay, so the question says, did you take into account the solid line on the top view? The top view, I'm not sure what solid line you are referring to. But basically, this plane over here is represented by that line over there. Okay, I'll leave this one on there for another minute or so for the people who are still busy drawing it so that they can complete the drawing. The question was, what does this dotted line represent? A dotted line is basically the same as a solid line. It is just when it is behind something. So that dotted line there represents this flat plane over here. Okay, so the next one we are going to have a look at is exercise 1, number 10. So isometric sketches exercise 1, number 10. We have 3 views given. There's a right-hand view, there's a top view, there would be the main view. And in my top view, I have this bottom triangle cut away. In my right-hand view, this top left triangle is cut away. The length is 1, 2, 3, 4, 5, 6, 7, 8 blocks long, 6 blocks high, 6 blocks deep. So the right-hand view is a square, this view is not a square. Okay, something like that. That's our box. And now we can start to remove material. So I'm going to start by removing this bottom corner in my top view, that one over there. So it starts 1 block from there and is about halfway in that line. Okay, something like that. Next thing that I'm going to do is I'm going to remove that triangle from my right hand view, the top left triangle, which is 3 by 3, so it's middle of that one to the middle of that one. Something like that. Now for the slightly more tricky part. I'm going to erase the construction lines there. Okay, so now for the tricky part that I mentioned. This plane over here is flat because that line in my top here is a straight line. So that means it cannot have this weird shape over there. It should just have a straight line from that corner down to that corner. You can see there it is a straight line. So it should have a straight line from this corner to this corner. Something like that. So if we now approach this drawing here from the bottom left, the first thing we meet is this rectangle that is 4 blocks by 3 blocks. Then if we go slightly behind that, at the top we have a block that is 3 at the bottom and more at the top. About 6.5 at the top. To the right of that, we've got one that is 3 at the front and full height at the back. 3 at the front, full height at the back. And this one is the first one we see from the top. If we go down from the top, the second thing we see would be that face over there, which is this one. This entire face would not be visible from the top. It would just be a straight line. That straight line there. And then from the right hand side, the first thing we meet is this slender rectangle. And behind that, this shape over here. Now the reason why this line seems longer than the 2 blocks given in my right hand view is because it is actually going into the page. Meaning, if this is my pen's length, if I turn the pen, it actually looks like a shorter pen because I'm not looking straight at it. So this line is longer than 2 blocks in reality, although if you view it from the specific angle, it only looks 2 blocks long. Okay, I'll leave this one on there for another minute for the people to copy it down. So there's a question now on where can you find the memorandums for all of these questions over there. So you won't be able to find the memorandum for all of the exercises in the book because then we can't use the book anymore. It's basically just discussed in class. I see someone has raised a hand. You're welcome to ask a question by typing it in the chat box. Good. So the next one we're going to have a look at is isometric exercise 2, number 1. So exercise 2, number 1. We're given a part that is 1, 2, 3, 4, 5, 6, 7, 8 long, 1, 2, 3, 4, 5, 6 high, and 6 deep as well. So let's quickly construct the box. So there we have the box. And now this one is a little bit more tricky than the previous ones because we can use a cutaway method, but the cutaway is at a very weird angle, which makes it very hard for us to do that slanted cutaway. So I'm going to show you another method in which you can construct these weird surfaces. So I'm not sure what the question, how to answer the question about the curve like a building wall. That plane on the right hand side is basically straight for the previous question. Okay, so with this one, what I'm going to do now is I'm going to sketch what I have available, and then I'm going to use that to construct this weird shape over here. So first thing to do would be to identify corners that match with each other. So find a point in one view and find its location in the other views as well. So for isometric drawings, we're not going to do auxiliary views. This is just a single 3D view. Auxiliary views would be helpful later on if you want to know the true shape of that weird surface. But we're going to do that in auxiliary views that we do in about 3 weeks' time. So let's start with a corner. I'm going to start with that corner over there. That corner in my other views, basically what I'm looking for is any intersections or kinks in lines. So if I project this one upwards, the only one that intersects with that projected line is this corner over there. Just for ease, I am going to quickly draw the question over as well. And in this view, will now nicely crash into this view. So I'm just going to do it slightly higher. Snap. Bad planning, guys. Okay, something like that. So there I just quickly copied over the views. So if I start with this point, let's give it a number. Point number 1. If I look at my top view, I must try to figure out where point number 1 can lie. The only place that lines up with this line projected upwards is this corner over here. So that's point number 1 in my top view. Point number 2 here at the bottom. If I project it upwards, the only place that can line up with that is well, now I have 2 options. It can be that one or that one. So for that, I'm going to use my right-hand view as well. Point number 2 to the right can lie over there, or over there. So if I now look at these 3 points and these 2 points, I need to figure out which of these could actually be point number 2. So point number 2 has to lie somewhere on the ground. This point, however, is somewhere in the air. It's at the top there. So this one cannot be point number 2. That one has to be point number 2. Then let's do point number 3. Point number 3 in my top view can only line up with that corner or the bottom one. Now I'll have to go to my right-hand view to figure out which of those it can be. There's a trick with orthographic projection. It's not too serious for you to understand it right now. We are going to do it in next week's lecture as well. Point number 3 in my right-hand view can only be the one on the ground. So that means point number 3, I said could be that one or that one. In reality, it can only be the one on the ground. Okay. Let's call that point number 4. In my right-hand view, point number 4 could line up with that corner, or it could line up with that corner. So it's hard to say from my right-hand view only. If I take it to the top, point number 4 can be there or there. So one of these two or one of those two, there can only be one answer there. Previously, we said that this point number 2 lies on the ground. So the only other option for point number 4 would be that one there, because this point 4 definitely does not lie on the ground. Okay, so that's point number 4. Now I'm just going to transfer these points over to my isometric view. Point number 1 from my main view lies over there. From my top view, point number 1 lies on the same place, 2 blocks from the side. Point number 2 in my main view lies over there. From my top view, it is 2 blocks from the side. Two blocks from the side. Now the question is, which one of those is point number 2? And I usually explain this by referring to a fish tank. I always use this fish tank example. Basically, if you're at an aquarium and you're looking at a fish tank, and we have some more other fishy in there. Now we can measure the distance that the fish is from the bottom of the tank, and we can measure how far it is from the side of the tank by just looking at the tank from the front. But what we can't see is how deep this fish is into the tank. So basically how close it is to the window or how close it is to the back of the tank. The only way in which you can get this information is actually by walking to the side of the tank and looking at the side of the tank. And only now can we see how far this little fish is from the front window. Okay, so, and remember the height from the bottom will still be the same as the other one. So basically what I can do is If I want to draw this fish tank in 3D, like an isometric view, and I want to find the location of this fish in 3D, I can draw the tank. And then what I can do is I can project the position where this fish should be in my isometric by taking the point on the main view, the distance from the side, the distance from the bottom, taking that point, and basically saying that the fish from this view looks like it is there, but I cannot judge how far into the tank it is. So it can be anywhere located on that line, because from this one direction, you don't have that information. Now we can do the same from the right-hand side. The fish looks like it is over there, but again, because it's a 2D view, it can be anywhere on that line projected to the back. And where these two lines intersect each other, that is actually the point where the fish would lie in the fish tank. So basically, you take the one plane, project it backwards, take the other plane, project it backwards, and where those 2 points intersect, that is where you will actually find the point. Now, the reason why I explained it like that for you now is point 2 in my main view lies over there, or it can be anywhere behind that. In my top view, it looks like it's over there, or anywhere below that. Those two lines intersect at the bottom there. So that is point 2 in my isometric view. Point number 3 in my main view looks like it is over here, or anywhere behind it. In my right-hand view, point number 3 is over there, or anywhere behind it. In my top view, point number 3 is over there, or anywhere beneath it. So where those three lines intersect is where the true location of point number 3 can be found. Point number 4 is in my top view. Top view, it looks like it is over there, or anywhere below it. In my front view, point number 4 looks like it's over there, or anywhere behind it. So this is the true location of point number 4. Okay, and then if you follow this process for point number 5, and so on, then you can actually construct the isometric drawing. There's a straight line from 1 to 2, straight line from 2 to 3, straight line from 3 to 5, straight line from 5 to 4. And a straight line from 1 to 4 as well. So if I quickly go and erase all my construction stuff, then that is what we are left, and that is the answer to this problem. I see we are also pretty much out of time now, so I will stop there for today's class. The next lecture is Thursday or Friday, and it will be on orthographic drawings. Ah, it's a pleasure. It's my job. For all of you saying thanks and whatever, okay, it's a pleasure. It's my job. And for the question, explain the numbers again. I think the easiest would be to just go rewatch the video. I will quickly share the screen again for those who need to just copy down the answer. Okay, so if you practice drawings and need assistance with it, you're welcome to take a picture of it and email it to Mr. Murray. He is our instructor. His contact details are under the lecturer information on ClickUp. Next question is the textbook where it says not for mechanical and industrial engineers correct? That one will work perfectly. That's basically just the previous version of the current one, but content is perfect. It has all of these exercises in it.